5.5.
We should have mentioned that story in the video.
Linearization and differentials. It's been doing that a lot recently.
What, your elbow?
My shoulder.
I had a burp, but it didn't come out.
I was wondering what was happening there. All right, so these problems say find the linearization L of x of f of x at x equals a. How accurate is the approximation L of a plus 0.1 is approximately f of a plus 0.1? See the comparison following example 1. Okay.
Hey, it's number 2.
It is number 2. F of x equals the square root of x squared plus 9. You want some scissors with that? A equals negative 4.
It took me a second to get the joke, and then he started laughing, so I knew.
All right, so just as a, well, I'm going to put it up here because it's not on my screen, but L of x equals f of a plus the derivative at a times x minus a. All right, so first thing I would do is find f of a. So we're just going to evaluate the function at a. So f of a, or let me do this, f of negative 4 is the square root of negative 4 squared plus 9, which is the square root of 25, or 5. We're not, like, that's only if we do, like, x squared equals something. This just was a square root that was already told to be positive, so.
Oh.
So now I need to find the derivative of f. So what's the derivative of this? And if we need to, we can think about this as the, not the square root, as x squared plus 9 raised to the 1/2, if that's helpful. Yes. All right, so the 2's here are going to cancel. This 2 and this 2 in the denominator are going to cancel.
Bye-bye.
So I end up with x over the square root of x squared plus 9. So now that's the derivative of f of x, but I need f prime of negative 4. So f prime of negative 4 is negative 4 over the square root of negative 4 squared plus 9, which we already know what that is. So this is negative 4 over 5. Then the x minus a part is just x plus 4. So I have all my necessary pieces now. I've got f of negative 4, I've got f prime of negative 4, and I have x minus a as well. So now I can actually do part A of the problem. Oh, not that. All right, so part A is just to write the linearization, which is L of x equals 5 plus, or I guess in this case it's minus, because it's minus 4/5. So minus 4 over 5 times x plus 4. Now, this is a linearization. So what do you think the answer ultimately is going to be?
A line.
A line. So this is 5 minus 4/5 x minus 16 over 5. And that ends up giving me, that would be 25 over 5, so 9 over 5. So then negative 4/5 x plus 9 over 5 is L of x. So this is my linearization. So they're not hard, they're just kind of time consuming. But I think this is still better than what we've been doing, so. Now, part B wants the approximation for L of A plus 0.1 being approximately equal to F of A plus 0.1. So L of A plus 0.1 means that I'm going to plug in for x negative 4 plus 0.1, and I'm going to get an answer. Then I'm going to do the same thing into the original. So first of all, I've got L of negative 4 plus 0.1, which is negative 4 over 5 times negative 3.9 plus 9 over 5. And at this point, we get out our handy-dandy calculators and do this. And I get a wonderful 4.92. Then I do f of this stuff. So f of negative 4 plus 0.1. So that's in the original, which is the square root of 3.9 squared. Or I guess it's negative 3.9, but it's going to be squared, so it doesn't matter. Plus 9. Which gives me 4.9203, I'm just going to round 7. So what do you notice? Basically the same thing. So what we need to do is we need to figure out exactly how accurate our approximation is. And so to do that, we do... I was trying to see if there's a specific order they wanted in. It's not going to matter because it's going to be an absolute value, but I was just seeing if there's a rhyme or reason. There's not. Okay.
Oh my gosh, we just decoded it. Number 2.
It was just a report.
That was their secret code.
She has to track it. Okay. Anyway, so we do.
She said she has to track it or she has to drag it.
The absolute value. Whoa, that was a really big absolute value of 4.92037 minus 4.92 equals 3.7 times 10 to the negative 4. So, what this means is the error is less than 10 to the negative 3. So, it's 1 less than whatever we actually get as our decimal. Basically means out to this digit, I'm right. Technically, there would be like a 0. I mean, because we can think about it, there's really a 0 there. So really out to here, I'm correct. Once I get to this 3, so 3 decimal places, that's what my error is. After that, it's different. is all that really means. So that's the how accurate part is what I've put there. Ooh, a fun one.
Ooh, fun one.
4, f of x equals the ln of x plus 1. And a is 0. And while we're getting used to it, I think there's some benefit to writing out the L of x equals f of a plus f prime of a times x minus a. Just until we're like super familiar with it. I think there's some benefit to that. And then that helps us just keep up with what pieces I'm finding. So the first thing we do is f of a. So f of 0 equals the ln of 0 plus 1. What's the ln of 1? E to the what is 1?
Okay, that makes more sense.
Thinking of it like that is.
The ln's get me. I don't know why.
All right.
Thinking of it like that, for some reason, takes me longer. I just remember my calculator said it, and I trust it. So.
All right. What's the derivative of ln of x plus 1?
Over x. No, stop. 1 over x. Is there more to that? Like, I know there's more, but like under the.
He just said it.
Aw.
1 over x plus 1. It's 1 over whatever's in the parentheses, and then if there's something more than just, yeah.
Okay.
If there was something else, we would also be chain ruling it. I mean, technically we are chain ruling this one, but it's just 1, so we just didn't worry about it. So now, evaluate at 0. So f prime of 0 is 1 over 1, which is 1. And then x minus 0 is just x, so I just kind of disregard. So my linearization for this one, a bunch of pieces are missing. I'll actually write in the zeros right now, but normally I just wouldn't. Is going to be L of x equals 0 plus 1 times x minus 0. So this just ends up being x. Then we're doing it at a plus 0.1 for part B. So L of 0.1 equals 0.1. F of 0.1 is the ln of 0.1 plus 1.
How far out do you want us to go?
I would say always go at least 4 on these ones.
Okay.
0.0953.
So then now, obviously, like I said, it's an absolute value bar. So on the last one, we technically did F minus L. On this one, it doesn't really matter because it's in absolute values, but I'll probably do L minus F just so I don't end up with a negative number. But it's absolute value bar, so it's not going to matter.
Mental.
Yeah.
It's
So
easy to look at.
absolute value of 0.1 minus 0.0953. Or 4.7 times 10 to the negative 3. So that means that my error is less than 10 to the negative 2.
or like, I think you just didn't write out like the steps because it was like canceled out. But like for the L of x equals x, and then like L of 0.1 equals 0.1, that was just like.
Yeah, this was just, so this is a plus 0.1, so a was 0, so I just didn't write it.
Okay. And then how'd you get the first part for part A, like the 0 plus 1 times?
It goes into this formula.
Okay.
The stuff we do before all of the.
Yeah. So all of this we found to be able to plug into the formula.
Okay.
I just do it before because I think it makes it easier.
Mm-hmm.
Some people just do it within it, but I think it can get too complicated with so much happening. So
I might as well just figure out what everything is and then
Yeah.
throw it in there.
and then just simplify it. It's nicer. Let's see.
Why don't you just let it when you understand the problem?
All right, these ones say to use the linear approximation 1 plus x raised to the k is approximately equal to 1 plus kx to find the approximate approximation for f of x for values of x near 0. So 10, these have 3 different ones that we're doing it for, so we have like an A, B, and a C. So A is f of x equals 4 plus 3x to the 1/3. So it's got to be in the form that's given to us here, which is 1 plus x to the k. So I need to factor out a 4, okay, within this to have it in 1 plus x raised to the k.
So like x can have something on it? X can have something on it? Like the 3 there?
Yes.
Okay.
But the number in front has to be a 1.
Oh, I understand.
So this is going to be, I just use brackets to make it look nicer. So 4 times 1 plus 3 over 4 x raised to the 1/3. Now with it broken down like that, the 1/3 can go on both pieces because it's being multiplied. So 4 to the 1/3 times 1 plus 3/4 x to the 1/3.
Somehow my x is like outside of the parentheses.
So whatever number ends up in front, so like in this case it's the number 4 raised to the 1/3. That will just stay with us for the remainder of the problem and move down. Now that we have this in this form though, I take, and it's going to be 1 plus kx. So whatever k is, in this case is 1/3, is getting multiplied by whatever's in front of x. Okay, so basically we're about to take this and multiply it here, which is going to give me 4 to the 1/3 times 1 plus 1/3 times 3/4 would be 1/4 x. And that's the answer to that one. So then B, f of x equals the square root of 2 plus x squared. So obviously this one doesn't look like the 1 plus x raised to the k, but I can rewrite this because I can rewrite my radical as 1/2. So this is going to become 2 plus x squared to the 1/2. Then like I did in the last one, I've got to have a 1 in front. So I'm going to factor out a 2. So I've got 2 times 1 plus x 1/2 x squared raised to the 1/2. Then I can split it. So I'm going to write it as the square root of 2 now. Times 1 plus, I'm just going to do this, x squared over 2 raised to the 1/2. Then this moves down in front, multiplies here. So I end up with the square root of 2 times 1 plus x squared over 4.
I know it's like the same thing, but it's okay if I write like 1/4 x squared.
Yeah.
Okay.
So I won't do c right now, but c is the cube root of 1 minus 1 over 2 plus x squared, like that. So we'll do that one tomorrow and do a few more example things, but there's not too much left in this section, so.